Hey everyone, and welcome back to my channel. Today we're going to be talking about an introduction to factoring. So, how we're going to go about factoring. Generally speaking, the simplest case is where you have a times b plus a times c, and you're going to take out the a, which is going to leave you with b plus c inside of the brackets. Now, provided that you watch my video on the distributive property, you might remember that this is the exact opposite of the distributive property, right? With the distributive property, we were taking a and distributing it to the inside, which would give us the left. Here, we're not after that. We're going from the expanded form into the factored form here. So the goal is going to be to take out what we call the greatest common factor, or GCF, and simplify. I'll show you what I mean in a couple of examples. Alright, so we're going to start with the following example here, which is 6x plus 3. Now, we can't add 6x and 3 for the reason that they are not like terms, right? 6x contains a number and an x, whereas the number 3 obviously is just a number. It doesn't have an x term. But what we can do is we can factor something out. So, to find the greatest common factor, we're going to start by writing out all the factors of 6, okay? So, for the factors of 6, we get that there is 1 and 6, but also 2 and 3. So I'm just going to write them in order. So 1, 2, 3, 6. Now for the factors of 3, we find that there are only 2 factors because 3 is what we call a prime number, right? So there are only 1 and 3. Now you might notice that there are 2 aligning factors here. You have 1, which is going to be common to every whole number. And then you have 3. So the question is, which one of these two is greater or bigger? Well, that's going to be 3, right? So what we're going to do is we're going to replace each of these terms. So we're going to put a 3 on the outside, and 6 divided by 3 is 2. So on the inside, we're going to write 2x. 3 divided by 3 is 1. So we get 2x plus 1. Okay, so we're going to proceed with the following example, which says 15y plus 25. And we're going to factor this example. So to start, we'll write out all the factors of 15. So factors of 15. Well, you might remember that we have 4 factors of 15, right? All the whole numbers that multiply to 15. We have 1, 3, 5, and 15. Now we pair 3 and 5 up, and 1 and 15 like that. On the other hand, the factors of 25, there are only going to be 3 factors of 25. We have 1, 5, and 25, right? Because 25 is a square number, 5 times 5 is 25, so we only write the 5 once. Okay. So, now my question is, which number is the greatest common factor between 15 and 25? Well, it would have to be the number 5, right? Because 1 is common, but that's a pretty small number, and 3, 15, and 25 are all unique. So we're going to write 5 at the front. Now, remember that for 15, 15 divided by 5 is 3, so we write 3y plus, and 25 divided by 5 is 5. So our final answer is 5 times, in brackets, 3y plus 5. Okay, so we'll move on to the following example here, which is 2x squared minus 6x. So, what can we factor out here? Well, the reason that I did this example is to highlight that we don't just factor numbers out, we can also factor out x's. So, in this case, the 2x squared term is 2x times x, and the minus 6x term is 6 times x. So we can actually take out an x. So we're going to go x 2x minus 6. Okay, and from this point, we can factor it just as we did before. We're going to ignore this negative sign for the time being, so we're just going to write out the factors of 2, which are 1 and 2, and the factors of 6, which get me 1, 2, 3, and 6. So the greatest common factor is going to be 2. We're going to take a 2 out. Remember that we have it like this. So 2 divided by 2 gives me 1. And 6 divided by 2 gives me 3. So what I'm going to get is 2x on the outside, right? Because I factored out that x and I factored out a 2, which means that they are going to multiply each other now. Now in the brackets, I'm going to get x minus 3. And that is my final answer. That's as far as I can simplify this. Alright, so I'll get you to try the following 2 examples on your own. So pause the video and come back when you're all ready. Okay, so to start with the example on the left, you can see that we have 3x minus 9. So we're going to consider the factors of 3. Now the factors of 3 are going to be 1 and 3. And remember that we don't want to worry about this negative sign right now. So we're going to go for the factors of 9. And I'm going to get 1, 3, and 9. Now they're going to pair up like this. And we can see that the greatest common factor is the number 3. Okay? So I'm going to factor out a 3 from everything. So start with 3. Then I open up my my brackets. So 3 divided by 3 is 1, which just gets me x, minus 9 divided by 3, which is 3. So that factors to x minus 3 on the inside. Now, we have the function on the right here. So we're going to start by taking out an x from all terms. So we're going to get x, 8x plus 8. And I'm sure that you could see this even without doing the greatest common factor method, that 8 is going to be the greatest common factor between these two, right? Because it's in both of them. So we're going to take out an 8 as well, which is going to give me 8x, x plus 1 as the answer for what's on the right. Okay, so I wanted to end off the video with these 2 examples. They're a little bit more conceptual. So the one on the left, we're going to take out the greatest common factor, but not factor fully. We'll get into how to do that fully over the coming videos. Whereas the one on the right is just variables. So let's start with the one on the left. So you can see that we have 3 terms here, and we can't factor out an x from all the terms because, right, there's no x attached to the 4. So that's not going to be part of the greatest common factor. So what we're going to do is consider the factors of each of these numbers here. So the factors of 2 are going to be 1 and 2. The factors of 6 are going to be 1, 2, 3, and 6. And the factors of 4 are going to be 1, 2, and 4. So you can see from this that 2 is going to be the greatest common factor, right? 3, 4, and 6 are all larger, but they're only in one term. And we want to find the factor that's in every term. So we're going to take out a 2. 2 divided by 2 is 1, so we just get x squared plus, and now 6 divided by 2 is 3. 3x plus 4 divided by 2, which is 2. Okay. And now for the example on the right, this is all variables. So we can start by factoring out that x variable there, which is going to give me x, xy plus yz, right? Just because x squared is x times x, which means that there's an x in both terms. And now we can factor out this y right here as well, because it pops up in both places. So xy, x plus z becomes the final answer. All right, so thank you very much for your attention, and I hope that this clarified the basics of factoring.